I'm Katharine Napora. I'm a postdoc in the Department of Anthropology, and I'll be talking today about how archaeology, like this photo of an excavation of a shell midden, basically an ancient trash pile from the Green River in Kentucky, this excavation took place in the 1930s, can help us today in the 21st century. So archaeology is a subfield of anthropology, the study of people. And specifically, archaeology is looking at what people left behind to understand the ancient past. That includes artifacts and eco-facts, like we see in this picture from a historic site in Kentucky. So here we can see ceramics, glass pieces, and eco-facts that include shells and animal bones here. So all of this contributes to our knowledge of the past in archaeology. So when I say archaeology, who thinks that Indiana Jones and/or Lara Croft are the first people who come to mind? Personally, yeah. So talking to a lot of people, that's very much the case. I know it was the case for me probably through like high school, knowing about archaeology. And so while Indy and Lara get to save the world from impending apocalypses and Nazi schemes, we don't get to do that quite so much. However, myself and my colleagues at the Webb Museum of Anthropology, we do get to conduct research that's really important, not only for illuminating the ancient past, but also for helping the 21st century. And so I'd like to talk about a couple of case studies that we're starting at the Webb Museum that really illustrate how this study of the deep past can help us in both the present and the future. The first of these studies is focused on conservation paleobiology, and that's basically using information about the ancient past to help conservation and restoration work today. So our study is going to concentrate on freshwater mollusks, like we see in this photo from the Green River, the same species that huge shell midden being excavated in the 1930s was composed of, and heavy metal contamination. So freshwater mussels are one of the most imperiled groups of animals in the world today. Kentucky has over 100 native species, but 20 of those are locally extinct in the state, and 36 are rare or endangered. So conservation managers, wildlife managers today, and state agencies are really trying to focus on how we can help these mussels to make a comeback in this state, reintroducing species that have vanished, making sure that the waterways are appropriate for population recovery. So this focuses a lot on this concept called shifting baselines. And basically we can think of this as what is natural exactly? So we look out today in a river in Kentucky, say for instance, the Green River, which this photo is of here. Again, same river that those huge excavations were on. Today we might see very depleted mussel populations and very few comparative species. So when we think about what was this like in the past, as people, we don't really have very deep memories generally. We tend to think of what we've seen in our lifetimes as well as what we've seen or heard from our parents and maybe our grandparents. So most people today, when we talk about 100 years ago, people think, wow, 100 years, that's such a long time. But for us in archaeology, and really for the history of the world, that's nothing. It's a drop in the bucket. So conservation paleobiology is able to shift what we think of as baselines. So what a river looked like in the ancient past, going back farther and farther into the past, we're able to push that baseline back farther. So going from historical sources, we may try to figure out what a river was like and what populations of mussels were like, say in the 1950s, which seems like a long time ago to a lot of people. However, by that point, these populations were already really depleted. Waterways were already very polluted with heavy metals and other contaminants. So that's not really an appropriate reference point for being able to understand how these populations should be able to recover. Going back as far as we can with historical records usually takes us back maybe to the 1880s. So even that's kind of verging on the limits of our collective generational memory. Archaeology is able to contribute something that history, written records, cannot in most places in the world. Specifically, we can contribute these very deep time baselines for understanding what populations were like a really long time ago before industrialization occurred. And that's not to say that this is natural per se. Native American communities were here in the US. We just learned for much longer than science has previously thought. So they were here at least 20,000 years before the present. So they were interacting with these riverine environments, impacting these environments, often in a very sustainable way, however. So we don't want to think about this as natural, but we do want to think about these populations of mussels and other species in the ancient past as being sustainable. And looking at what contaminants were like in the ancient past can help us figure out baselines that we want to get back to today for restoration. So again, here's another photo of the Green River in Kentucky. So mussels, if anybody knows, kind of like tree rings, grow in layers. These are two ancient mussels that lived about 4,000 years ago from the Green River here in Kentucky that these guys are sitting on top of in the photo. So mussels, like trees, record environmental conditions over their lifespan. We can actually see changes in seasons and changes in years through their growth bands. So our study is going to be looking at heavy metal contaminations within these mussel shells and figuring out what heavy metal levels were like in rivers before pre-industrialization when mussel populations were at a good sustainable level. We'll be then sharing that information with state agencies and wildlife managers to ensure that it's actually used to try to improve restoration and conservation today. Another really important thing that archaeology can contribute to the conversation in the 21st century is illuminating these diverse experiences. Phyllis, my colleague in anthropology this morning, spoke about how her research is helping to show how ordinary people lived in the past, because through historical records, we mostly have records of the rich and famous, largely white men in the history of the Americas. However, with archaeology, looking at the artifacts that people created and left behind, we can learn about other people too. This is a huge wooden trough held at the Webb Museum of Anthropology where I work. And oral history tells us that this trough came from Mammoth Cave, and it was probably used for mining a component of gunpowder in the early 1800s. This gunpowder mining was looking for saltpeter, which is calcium nitrate. It was being mined in Mammoth Cave and other caves in this region. And this was largely done by laborers who were held in bondage, African Americans. So these people who were held in bondage, we can see in this architecture they left behind. Here's a diorama showing what this might have looked like mining in the main cave of Mammoth Cave in the early 1800s. We can see really their ingenuity and their engineering skills through these artifacts that they created and left behind. So our study is going to be figuring out if this artifact is an important artifact that shows part of that underrepresented history. We're going to use several scientific archaeological methodologies to verify this artifact's biography. So first of all, we'll figure out when this trough was made exactly. We can use radiocarbon dating, which uses the decay rate of radiocarbon over time to figure out an age range. And we're going to pair that with dendrochronology, which is tree ring dating. And it can provide us with an exact year that this tree was cut down to make that trough. We're then going to figure out where that tree grew. Was it near Mammoth Cave? We can also use dendrochronology for that. Tree ring patterns match the best against other trees from their specific location. So we're going to compare the ring pattern of this big trough to ring width patterns from different tree rings chronologies developed around the Kentucky and Tennessee area. Hopefully it will show us that indeed it was cut down in the Mammoth Cave locale. And if we look at this trough, we can see this sort of white crystallization coming out of it. We think that that's probably calcium nitrate, which is what was being mined in the cave. So together, these analyses will help us verify that this trough is indeed an artifact created by enslaved African Americans or in the early 1800s. We're then going to reach out to Mammoth Cave National Park, as well as the descendant community, to try to create a small exhibition to show how archaeological science can help illuminate these diverse stories in the 21st century. So in conclusion here, this is just 2 ways out of many that archaeology helps the 21st century. We can look at ancient environments as well as artifacts, and from that, we can tell things about what conservation baselines ought to be, as well as bring diverse stories to light. And thank you all. I'd like to invite you to visit us over at the Webb Museum on Export Street to learn more about how our work on the ancient past is helping the present and the future.